Okay, so we will be doing just a quick introduction here with real numbers and just things that we're going to do with real numbers. So first of all, our operations are plus, minus, multiply, and divide. Those are the things that we do with the numbers we talked about last time. Constants are just elements of the real numbers. Remember what that notation means? Variables are symbols or letters representing numbers. And expressions are just a combination of the above. If we take a bunch of operations, constants, and variables and mix them together, we'll end up with some expressions like these right here. For evaluation, we're just going to take a number and plug it in and see what comes out. So if we know A is 1, B is 4, and C is 7, we'd plug 7 in for C, and we get 100 minus 7 is 93. A plus B plus C would be 1 plus 4 plus 7, or 12. 2A plus 3B, that would be 2 times 1 plus 3 times 4, 2 plus 12, which is 14. BC minus A, 4 times 7 minus 1, over A plus 2, that would be over 1 plus 2. We do our multiplication first. We'll talk about y in just a second. Give us 27 over 3, which is 9. B to the n, as b times b times b times, so we multiply b times itself n times. So if we had 2 to the third, it's 2 times 2 times 2, which is 8. If we had b squared, we're going to keep b as 4 because it was 4 on the last slide. That's 4 times 4, which is 16. 2/3 times 2/3. Don't get scared of fractions. Multiply straight across. 2 times 2 is 4. 3 times 3 is 9. So if we know the definition of squared, square root's just the opposite. So the square root of a is b if a is b squared. For example, the square root of 16 is 4 because 4 squared is 16. The square root of 25 is 5 because 5 squared is 25. The square root of b is the square root of 4. We're going to keep a, b, and c the same for this lecture. The square root of 4 is 2. The other square roots that we know, square root of 9 is 3 because 3 squared is 9. Square root of 36 is 6 because 6 times 6 is 36. Square root of 49, square root of 64, square root of 81, square root of 100. All those easy times tables that they're usually the favorites of people in elementary school. How can you approximate a square root sign with a square root without a calculator? Well, if we know we don't know square root of 40 because that's not one of the easy square roots, but we do know that 40 is in between 36 and 49. And 36 and 49 we know, so that means the square root of 40 is somewhere between 6 and 7. That's how last lecture I was able to say the square root of 6 is between 2 and 3. So now we know the square root of 40 is between 6 and 7. We could plot it on a number line if we wanted to. Okay, mnemonic for remembering the order of operations. There are a lot of them that I've heard, but by far the most common is please excuse my dear Aunt Sally. I like please excuse my dear Aunt Sally, but the one drawback is that it can be a little misleading. If you change it just a little bit so that it says please excuse my dear Aunt Sally, it's a lot better. The reason being, P stands for parentheses or any grouping mechanism, E stands for exponents or any roots, M and D stand for multiplication and division, and multiplication doesn't come before division. Aunt Sally stands for addition and subtraction, and addition and subtraction again are on the same level. We have to do, if we have both multiplication and division in a problem, we just go from left to right and do what we encounter first. Same with addition and subtraction. For example, if we have 12 divided by 3 times 2, I tell you, you could stump a lot of people with this question because please excuse my dear Aunt Sally is so ingrained that they want to take 3 times 2 first, but you can't. You have both multiplication and division in that problem, and multiplication and division are on the same level. So we take 12 divided by 3 first and get 4, and then we multiply by 2 and get 8. You can't do the 2 times 3 first. So here are some examples. 7 plus 3 times 4. Do our multiplication first and then our addition. 7 plus 3, we do inside the parentheses first and then our multiplication. 3 squared plus square root of 16 plus 2. We do our exponents first. There aren't any parentheses. The exponents are 3 squared, which is 9. And remember, a square root sign counts as an exponent, so we'll do square root of 16 is 4. Next, we'll do our multiplication and then our addition. Now we've got 2 sets of parentheses. Which ones do we do first? Okay, 6 minus 4 is the very inside set of parentheses. We work from the inside out. So we do 6 minus 4 first, and then we do the multiplication inside, and then we do the addition inside, and then we do our final multiplication. Work from the inside out. 18 plus absolute value of negative 3. Absolute value of a number can never be negative, so that becomes a positive 3, and we get 21. 2 times the square root of 9 plus 16. P is for parentheses. I don't have any parentheses, but I do have a grouping mechanism. That square root sign groups the 9 and 16, so I have to add those before I take a square root. Square root of 25 is 5, so I get 10. Okay, and my A, B, and C are going to be the same A, B, and C that I had a few slides ago. A is 1, B is 4, C is 7. So I have 1 plus 1. It's inside parentheses, so I do that first. Then I have an exponent, then I do my subtraction. For this one, I substitute everybody in. Again, I don't have parentheses, but I do have grouping. That numerator is grouped together. So I do 1 plus 3 is 4. I get 4 over 4, which is 1. If I made a mistake, where would it be? It's possible you could make it here by doing the addition first. I don't see that mistake very often. There are 2 mistakes I see a lot. There's this one right here. People multiply that 2 to the 16 before they take the square root sign. Now, it's kind of hard to do that when it's typewritten because you can see that square root sign ends over 16, but when you handwrite something, it's sometimes hard to see exactly where that square root sign is ending, and it might get too long or too short, so be careful with that. And the last one I see is people that are very tempted to take the square root of 9 and the square root of 16. We can't do that. You cannot split the square root over addition. You have to add first. That square root sign acts like parentheses, and it says you have to do that addition first. Okay, translations. Here's kind of our translation dictionary. Sum total plus increased by gain, raise, and more than all mean add. There might be more, but those are all that I could really find. Subtract, difference decreased by less than, fewer. Take away, subtracted from, and minus. Those that are asterisked are because the order in which things are written in English is different than the order in which things are written with math. For example, if I had x less than a number, or x less than 5, it would be 5 minus x. If I had 10 less than x, it would be x minus 10. The order switches between English and math. Multiply, those are the multiply words, and divide, those are the divide words. So if we had 4 times the sum of x and 2, 4 times, just go a phrase at a time, 4 times, that means I'll multiply by 4. What am I multiplying by 4? 4 times the sum. Okay, so I've got 4 times the sum. It will really help if you'll write this down in pieces. 4 times the sum of x and 2, so it's 4 times the sum of x and 2. Now this one looks very similar, but it's actually quite different. It's the sum of 4 times x and 2. So it's the sum. What am I summing, or what am I adding? I'm adding 4x and 2. See how they're the same, but it's also important to see how they're different. Twice the difference of x and 7. Start with twice the difference. Twice, multiply by 2. What am I multiplying by 2? I'm multiplying a difference, so twice the difference of x and 7. The product of b and 6 is just b times 6. We usually write that as 6b. 3 less than x is x minus 3. So that's the tricky one. English and math are in a different order, so be careful with those. Okay, don't take notation for granted. Math used to be written out longhand. We didn't have all this notation that you probably don't like a whole lot, but it's a whole lot easier than trying to solve a math equation that's totally written out like those black phrases.